Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to this DevOps.com program, brought to you by Techstrong and Stormforge. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting program ahead. First, I do just have a couple of housekeeping notes to cover. So today's session is being recorded. If you miss any of our discussion, or maybe you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we want you to send those in to us using the Q&A tab, which can be found on the right side of the screen. We've reserved about 15 minutes at the end of the program to address as many of those as we can, so be sure to send them in early and send in as many as you'd like. And of course, before we close out, we are giving away 4 $25 Amazon gift cards, so be sure to stick around for the duration of today's program. So the title of today's program is Autoscaling Kubernetes Applications with Continuous Optimization. And I'm joined by Brian Lickasaur, Director of Global Solutions Architecture for Stormforge, Yasmin Rajabi, VP of Product at Stormforge, James Governor, co-founder of RedMonk, and Chad Upton, VP of Infrastructure Engineering at First Up. So I'd like to thank our panel for joining me, and I will give the floor over to Yasmin to take it over.
Thank you, Cody. Hello, everyone. My name is Yasmin Rajabi, and I am VP of Product at Stormforge, and I'm super excited to have you all here for this webinar today. We will be talking about autoscaling Kubernetes applications with continuous optimization. First off, I just want to go over the agenda a little bit. We'll spend a little bit of time on the panel talking about the autoscaling challenges that come with these and hear from experts on the impact of cost efficiency and application performance. Then we'll talk about our new Stormforge release, where we introduce bidimensional autoscaling. And then lastly, as time allows, we'll go over any questions that come up around Kubernetes optimization with the Stormforge platform. With that, I would introduce today's panelists. Chad, could you please start us off?
Sure. My name's Chad Upton, VP of Infrastructure here at First Up.
Thank you. James, would you please introduce yourself?
Yep, James Governor, co-founder of RedMonk, a research company. We spend our time trying to understand the choices that practitioners make, driving infrastructure choices more broadly.
Thank you. And then Licko, could you please introduce yourself?
Happy to. My name is Brian Lickasaur. As Yasmin said, I go by Licko. I lead our solution architecture team globally here at Stormforge. Real excited to chat about this topic because it's close to my heart.
Awesome, thank you. And so with that, I want to start off the panel by asking you, Licko, let's start with the basics. What are the autoscaling options that are available to Kubernetes users? And what are some of the challenges that come along with it?
Oh, sure. So there's two autoscaling options that kind of come out of the box, so to speak, with Kubernetes. There's the vertical pod autoscaler, or VPA, and the horizontal pod autoscaler, or HPA. And the vertical pod autoscaler is been around for quite some time, but there's been very little uptake. And I honestly, I'm not sure why in a general sense. I know some specific customer stories that I found interesting where people have said it's too complicated or takes too much investigative work to set the boundaries in which it's going to work. And I can imagine there's a lot of mechanical Turk that might be involved with doing that. The more popular of the two would be the APA. And that's because this is kind of what saves us from the influx of demand for our applications. So, we'll take the proverbial retailer with the busy time of season or the new sale that's going on where they have such a crazy interest in demand, they create more replicas based on the load. And those tend to be done in what I would call a very simple templated way where we'll say arbitrarily 60% CPU utilization, I need another. And, you can make a debate or an argument about whether or not that's a good point, like why 60%? In fact, I like to ask people that. I'm like, well, why'd you pick 60? And the answer usually is, well, when I copy pasted, that's what it was in the source. And I don't know, like maybe that's not right for your environment or your application. Have you, Chad, have you seen that at all? Is that something that you faced when you were first setting this up at First Up or anything like that?
Yeah, when we were migrating from EC2, we were auto-scaling a lot in EC2. One of the KPIs that we monitor very closely is time to scale. And it's basically how long does it take from a scaling event saying, hey, I need more instances, I need more resources, and how long does it take from that event till it can handle the traffic? First up's a workforce communications platform. So we have moments across all of our customers that they send out large communications. Millions of users could be clicking on, a newsletter or a CEO video or whatever, right? So you can go from 0 to 100 very quickly. And so that time to scale is really important on our platform. So when we were migrating, we actually decided to do a much lower threshold for scaling up. Our initial scaling event was 30% because we wanted to leave plenty of headroom for those instances to take more requests, but we wanted to scale up really, really quickly across the number of pods we had so we could handle that burst traffic very quick. So, but again, those resources and those thresholds, they kind of come from previous learnings, and they're not always exactly a one-to-one match to what Kubernetes does. So it definitely takes some tuning.
Yeah, for sure.
James, from your point of view, what have you seen as some of the challenges that come with autoscaling Kubernetes?
Well, I think it's classic Kubernetes, isn't it? It's like, it says autoscaling, so therefore it's going to be autoscaling. And then you're like, oh, okay, what is our autoscaling strategy? And it's like, hang on a minute, I thought it was autoscaling. Am I doing VPA? Am I doing HPA? Am I doing cluster autoscaling? Let's talk about those three things. It's like, wait a minute ago, it's what is this word auto? I mean, I thought that meant it was automatic, and now you're asking me to configure all of these things. So I think customers are confused. I mean, we've seen this in various areas with Kubernetes. There is a lack of skills. We'll talk about that, a little bit more. But I think it's just, largely you begin with an expectation that, oh, okay, Kubernetes, it's our orchestration platform. So we've got these containers, and it's going to industrialize them for us, and it's going to run them for us. But it turns out it's a lot more complicated than that. And I think that in numerous areas we've seen that. Whether we're talking about security, there's a lot of complexity in the platform, and that's something that enterprises definitely need help with, and even sort of born on the web companies are struggling to get their heads around and their arms around the complexity that's there. So, that's I think one of the reasons why we don't necessarily see as much taking advantage of some of the functionality that we might otherwise expect.
James, it's funny when you talked about all the different autoscalers that are out there, because there's more than that. I didn't list them all off because, frankly, we probably don't have time. But
I know I said three, but let's spend the next 25 minutes reeling off more technologies for sure. Go ahead,
sure.
Brian.
But where I was going is, I think a lot of folks also don't enable anything at the Kubernetes layer because they assume the cluster layer will handle it for them. So they're like, well, cluster autoscaler is going to solve all my issues and cure what ails me. But the challenge there is that it still does what it's told. So if you're saying at the pod level, well, my pod needs 4 CPU, 8 gigs of memory, then the scheduler is still going to say, I need a node that has that. And so therefore I can never scale down. And so I think our nirvana state of autoscalers is to scale it all the way down when we don't need it and scale it up as we need it. But it has to respect and listen to what it's told to do. That's just how it works. And so, like everyone thinks that's their saving grace. And it's like, I don't think it's doing what you think it's doing.
No, I think that's exactly right. I mean, scaling down is something that obviously is an aspirational state. But I mean, it's a bit like, I have kids, and I would love to be able to scale down the lights when they leave the room. But honestly, it's a bit like that with the systems we're running. That requires a lot of thought about what that means, what the service levels should be like at any given time. Again, there's a lot of work that goes into scaling down, frankly. And yeah, I think that's exactly right.
We almost take it for granted because when we're building these systems and these architectures, we're worried about scaling up. That's kind of our mission statement is I've got to scale up to meet demand. The scale back down piece is almost an afterthought, right? It's like, yeah, we scaled up to do it, but what about scaling back down to the minimum needed, right? What's the MVP of what we're cost optimized for? And that problem doesn't come till much, much later in kind of your platform lifecycle. So it's an interesting problem you will hit at some point.
Chad, what does that problem look like at First Up? What are some of the challenges you face when you do kind of hit that point?
Yeah, you scale to meet customer demand, right? And you add these resources and you start adding more services, and you get to a point where you're like, our cube clusters are running great. They're stable, they're performant, they're doing well. And then you start looking at your cloud bills and you're going, you know what? We're kind of like spending a lot doing some of this stuff, right? And start looking at where the costs are coming from. And you're like, man, we're spending a lot in, EC2 nodes or AWS nodes or Cube nodes, whatever you want to call them, or GCK, they're all the same thing. And you start really getting into it. And once you start looking at it, you start looking at, okay, what's my year-over-year cost increase for something like just EC2? And you start really looking at it like, you know what? We're actually quite a bit over provisioned for what a lot of these workloads are doing. And you just start taking, tactical approaches to certain services and saying, okay, these are some of the foundation ones. They scale up and down a lot. Are we really doing it the most performant, cost-efficient way? And you might get one or two or one or three processes, pretty dialed in. And then you take a step back and you realize, okay, well, I have 2 or 3 regions. I have 3 or 4 environments. I have, 50 plus microservices. Every one of them have, multiple processes that are running inside those deployments. How am I going to scale that? And then you start looking, okay, well, who's going to own this? Who's going to start working through this initiative? And you almost have to hire a full-time engineer just to manage, resource scaling at that point. So, I mean, it gets pretty overwhelming pretty quickly.
Yeah, I'd say, Chad, it's not even almost. I mean, it is. I mean, there are people with teams, there are people with those roles. And it's not just you. I mean, at the hyperscale or at the super scale, level, and you have the likes of Spotify, where they found, they basically the cost of infrastructure was growing faster than, like user acquisition. And that's a curve that you don't really want to have. They went on a whole mission. They went on a whole mission around bending the curve, so that Spotify could say to itself, hang on a second, we can actually grow that user population. And this is a problem that certainly very big companies have. But that's a company with that can throw resources at people. They have a culture of trying to not do that. So teams will, in fact, there's very much like, can you find a way to reduce cost with automation? And if so, there will be FTEs, there will be new engineers that are enabled by those efforts. So that's at the high scale. But it could just be a bank that doesn't have quite that level of expertise. And frankly, they're running into some of the same issues. So this is a very common issue where your user acquisition is getting out ahead of infrastructure cost. And, that was hard enough, in the sort of the frankly, the kind of the peacetime economic environment of 3 years ago, where there was a lot more funding pouring in, whether you were publicly traded, whether you were privately funded, VC funded or whatever. But at the moment where everybody is trying to drive costs down, you may not get another funding round if you're unable to show the strategies that you've got in place in order that actually you can keep costs down.
Yep.
Yeah, if it's a trend line, not just an anomaly, then you got a real problem.
Mm-hmm. Oh yeah, absolutely.
Yeah. And
especially as you start getting into, most companies right now are getting into 2023 budgets, right? You're starting, your budget strategies and type stuff like that. And cost optimization for infrastructure costs is kind of at the top of the list, because that's probably one of your highest spending allotments on your budget today, outside of, personnel, of course. But yeah, it's definitely top of mind.
And I'm curious, it's a pretty good lead in to kind of follow up on what James mentioned with the Spotify example of what are some of the business impacts when this doesn't go well, when teams are attempting to reduce their resource utilization, but ending up with inefficient auto-scaling? How does this really impact a lot of the organizations they do?
Well, for us, our teams are built to be very autonomous. They're very accountable for their own services, their own resources, their own tooling for the most part. And so a lot of the time what we spend the platform engineering and the infrastructure side on is reducing friction and allowing them to think about infrastructure less, right? Think about the stuff that really matters, performance, latency, tooling, those kind of things. So you throw something like, or insecurity as well, right? Which is its own big goat bucket. But you also throw in things like, hey, you need to make sure your production check, your production readiness also has what your resource requirements are.
Chad, did you say goat bucket, or is that something we're going to need to bleep out in a minute? I wasn't
big
sure.
Old bucket.
Oh,
Big
okay.
Old bucket.
Big old bucket.
Yes.
Oh, I thought you said something else. Sorry, there you go.
No, not a big goat bucket.
Now we have to censor what you said, James. See, that's
I also thought it could. Yeah, I thought you'd said something else. Actually, I was like, oh yeah, no, that's what a lot
I was
of
trying
people
to slide
say.
it in there for the beeps later. No, yeah. So adding something like, and it's really hard for a service that hasn't even launched yet, right? You can do a lot of load testing, you can do a lot of initial user provisioning and stuff like that. But until it really starts hitting that burst capacity as it's performed, you really don't know a lot of the times, what your SLAs are going to be from a resource standpoint. So almost every single time what they do is over provision, right? And that leads to, okay, well, it's working, don't touch it. And then it ends up in prod. Look, it's working. You don't want to touch the resources. And it's like, do you really need 4 CPU and 8 gigs of RAM for a Go service? Probably not. But hey, it's working. Don't touch it. So you get into kind of arguments around that too. So
I've occasionally seen where some folks left to an application group, they're told, hey, get more optimal, and they really geek out on it and they go crazy and they get too thin to where they're like, I'll put a buffer of 10 millicore on my CPU. I'll be fine. I'll buffer of a couple megs because I know this will only ever use 550 megs. Well, guess what? You're in an umkill loop. How do you feel now? So it's the other side of the business aspect, because the business, it's funny how many different people we end up serving in our organizations, right? Like you have that one constituency who's like, you need with 5 nines and it needs to respond this fast and all these things, and then but it also needs to be really, really cheap. Like you're spending way too much money.
Exactly.
And these two don't necessarily coincide as nicely as we'd like.
Yeah, it's like the 3-pillar strategy, right? You have performance, you have cost, and then you have stability. At some point, some of them have to give, right, to be able to do the other ones. Like you can't have all 3 all the time.
Or the old joke, pick 2.
Yeah, exactly, pick 2. So, no, for sure.
James, something that you touched on earlier, but I want to come back to is the skills gap. So organizations are trying to tackle this problem. Chad talked about their example at First Up of how they're kind of going about scaling and reducing their resources. We've talked to a lot of different customers that are kind of in the challenge of how do I tackle this problem at that scale? When Chad was mentioning all the different resource settings across all those environments, starts to add up. So what have you seen from a skills gap perspective of how people are trying to address this?
Yeah, well, there's just a lot of complexity. I think that's why the platforms emerge. Initially, at least, it was, oh yeah, we can do vanilla Kubernetes and everything's going to be great. We're going to be able to run it on-prem or in the cloud, or and we'll it's just going to be fine. We'll have this kind of vanilla thing. That's not the case. I mean, that's why the platforms have emerged. Chad was mentioning, whether you're using Kubernetes from Google or Amazon or Microsoft, the truth is that then that adds another level of complexity, because all of those systems, you've got different management interfaces, slightly different APIs, slightly different strategies. You've got different instances within those systems that you've also got to think about. And quite frankly, yeah, I mean, to my point earlier, it was hard enough when it was like, oh, well, we'll just, it was difficult for enterprises because they're like, we can't afford to compete with Netflix or a Google or whatever else. Our best people will end up there. Look at Apple. I mean, Apple now, they're hoovering up all the Kubernetes talent. I mean, I look at all these people that were like the original, so many people like in that original Kubernetes community. And it's like, oh, they're at Apple now. So Apple hired them all. So where am I going to find them? So when I talk about the skills gap, and I know that Chad has some pretty strong opinions about this sort of, and I'll let Chad talk about that in terms of what kinds of skills to expect and what you can teach. But yeah, the truth is that we are, as an industry, struggling to be able to, and it's on both sides. Do we have dev teams that fully understand building microservices to take advantage of the infrastructures? But then the people that are managing those infrastructures, do they have the skills themselves? So that one of the reasons that people are looking for platforms and tools and optimization tools is that there just are not enough skills and people to go around.
No, absolutely. I completely agree with that. We've hit many cases where it's weird where the current kind of state of DevOps is right now. And you've almost gotten too much of the automation on kind of some of the infrastructure side. So a lot of what we used to call system engineers or, system operations, that kind of thing, right? Or system admins. They were really hardcore Linux guys, or Microsoft, depending on which side you were on, right? So a lot of them knew the tooling around Linux and that kind of thing. And these guys and girls kind of graduated into DevOps or, one of the other pivots of that. But when Kubernetes came along, it was like, okay, now you've got this core architecture orchestration engine thing that you need to master. And oh yeah, you need to master it in that cloud and on-prem and that cloud, right? And then it changes like every 3 to 6 months. It starts adding, it's an evolving thing.
eBPF is coming, right, Chad? So right. eBPF, deal with that,
You just got to keep up with it. And it's like, oh, by the way, we also want you to develop software and make sure you know how to write tooling. And have you developed CI/CD platforms before? Great. You start laying on all these things that you're expecting. And then it's almost like you step back and you go, can I just hire a software engineer and teach them DevOps? Because that's almost easier at this point. Right?
Well, and you didn't, I don't think you even, maybe I missed it, but I don't think you even mentioned automation. I want you to also automate all this.
Yeah, you got to also automate all the things, right? And there's also that developer ecosystem stuff, because we are writing software that we need you to make better. And, it just kind of keeps on stacking up of what you expect. So you're in a weird market right now where skill sets, you might get like 1 of 5 or 2 of 5. And they might be, great at one of those. But then you're expecting them to take on all this other stuff. It is very intimidating for a lot of engineers.
I mean, you said pick 2, and that we were talking about picking 2 of 3. Now we're talking about picking 2 of 5.
Exactly.
So yeah, definitely need some automation in there, Liko.
Yeah, and I've I recently got a promotion. I'm not patting myself on the back, but that means I'm in the role of hiring and firing folks now, right? So yeah, okay, yeah. But I have to look for folks who have these skills. And the challenge, and I'm not trying to say feel sorry for me, but the challenge is even more interesting for a technology that is solely based on Kubernetes and is leveraging what Kubernetes does, because now I need a Kubernetes expert who also is an expert in every cloud provider and every different on-premise deployment methodology and every sort of CI/CD GitOps sort of magic they may be doing, because we have to meet our customers where they are. We never know what that's going to be. Everyone has an arguably unique combination of technologies they've chosen for better, for worse. And sometimes, and Chad, you don't have to confess this if you don't want to, but a lot of times you end up having all of the tools or many of the tools, right? Oh yeah, we're still transitioning away from that one and onto this one. And so now you have to integrate Kubernetes with those two, even though they kind of do the same thing or maybe are diametrically opposed in some cases. So it's such a juggling act that I don't know that the best jugglers in the world, like, what do they get to? 10 things at once? I don't know how high it gets, but here's what we're asking humans to do. And yeah, I don't know how we do it, but then at the same time, James, to your point on maybe Apple gobbling them all up or whatever, what that also does is an interesting point where they price folks that you would want to get the talent you'd want to attract out of market. And there's only so many, free snacks in the office, which is such a 2019 thing to say, that you can give to somebody. So you've really got to make the culture right, like all these other things. And it's almost a bigger deal because of the complexity of Kubernetes being the abstraction layer on top of an extraction layer on top of an extraction layer that we work with.
Yeah. And I mean, you also get into the bucket of, great talent. Great talent brings in other great talent, right? So it's for a startup that's coming out. You almost have to bring a team with you when you hire those executives or those VPEs or whatever, right? Because you've got to have a starting point somewhere. And if you don't, and you're coming in and you're like, build a team, right? As you know, Brian, Aliko, and James, you're like, hey, go hire some DevOps and software engineers and platform engineers and people to run infrastructure. And you're like, okay, wait, you get one. Where do you want me to start? Because we're hiring and it's going to take a while. But
did you just ask me to find a yarn? Okay.
Yeah, exactly. So
a lot of what we at Stormforge kind of talk about is how we can use machine learning to help augment some of those skills gaps. And so rather than asking your users to set these things manually or think about it, that's where the machine learning comes in and helps the operators, helps the developers make better, smarter decisions. I'm curious what your perspective, Chad, is on the impact of technologies like this to organizations like yours.
Yeah, anytime that you can, it's almost kind of, it happens organically. Like I said, you start building this EC2 fleet, then you move to Kubernetes, you start migrating all these services, and then you find your point in your product, your platform lifecycle where you're like, hey, I need to start optimizing costs around resources and those type of things. So you start looking, who does this? How do they do it? Are there tools out there? Are there open source? That kind of role. And it's funny because the problem very intricately. It's like, I know exactly where there's like this knob, and this knob. I need to tune across all of these things. So it was actually a really interesting, organically grown, reach out looking for Stormforge. And it's like, hey, this is what I'm trying to do. And you guys are like, hey, do you use VPA? And we're like, no, we don't. We don't use VPA at all. We actually only scale using HPA. And I'll be right back. So it's kind of grown organically that, what's happened and what's grown and kind of the way it's starting to work, but it's definitely going to solve a core problem for us. And, that's really what I'm excited about.
I love that. And promise to everyone watching this, we did not pay him to say that.
Oh, no. This is kind of one of those things that, anybody who grows up with DevOps, you have some of these tools that you pick that you're like, no, that's my jam. Like this is coming with me everywhere from now on. This is one I'm kind of excited about because it may be one of those, over my career that, I just bring along with me because it solves that problem that I don't want to hire an engineer to go do. And it's not something. Go ahead.
Ironically, Yasmin, I think Chad paid you to say that.
Right?
So,
almost.
So there you go.
So we have a couple minutes left in the panel. I just wanted to end it on James asking you your thoughts as an industry expert on how you see technology like machine learning helping address these challenges for organizations.
Yeah, well, I mean, I guess from my perspective, we can get very carried away with machine learning as an industry. We talk about it, AI, machine learning at the moment. We're getting there are a lot of very cool things. Stable diffusion, DALL-E, that stuff. We're getting a sense for, wow, look at what this could do around creative industries and so on. But in terms of solving core business problems, I just think that it's not always clear where machine learning is going to demonstrate its benefits. There's been a lot of talk and perhaps not quite as much action, and there's been a lot of expectation that the user would. So that the developer is going to know how to do this. Now, to take a step back, and I'll just finish up, there is one, I think, that was a canonical example, great use of machine learning, which was Google optimizing the power consumption in its data centers using machine learning, and they got significant benefits accordingly. We're talking about that sort of pattern in this space, where it's about optimization of resources, and that's something that machines are good at, and we should take advantage of that. So I just think it's a sort of a natural home for that kind of technology.
I think the other thing that our customers have been telling us is they when they do, like my team's responsible for proofs of concept, so they'll be trying out the Stormforge solutions in one environment to see how it's going, much like Chad is. And when they do that, they're like, okay, so I want to do this across this entire cluster. Wait, no, I want to do it across all my North American they start getting wider and wider, and I'm like, okay. So everything you did there, because of course there's an element of trust but verify, right? Like as they're using our solution, they're like, I trust your machine learning, but I want to see it before I go broad with it. And then they get excited arguably the moment they see it, right? The proof's there. And so they're like, okay, I want to keep going with it. And I'm like, okay, if you start to apply all those boundaries that you had talked about by hand across every namespace, across every cluster, how many is that, and how much thought do you have to put into that? And we're back to the manual problem again. Like it's a scale answer, if you will, so that now, like James, to your point, machine learning is very good at that. Let it do what it does and let it go. And sure, I'm not telling you, hey, go do this in prod tonight. Like, I'm not saying that, but maybe it's a great opportunity to try it in a lower environment where arguably you're spending more money anyway because we spend so much time figuring out in lowers to do what we do in prod. You can get the savings there that you want, get the confidence that you need, and then you can keep running with it. Like, that's the part I like about what the machine learning is doing for us, is that it's the automation and scalability pieces that at the scale of Kubernetes objects, we can't keep up with as humans.
Right. I think one of the coolest things that I saw come out of our kind of proof of concept was, hey, we want to apply this in our staging clusters, like where there's almost no traffic, right? It's engineers developing and testing and QA regression and that kind of thing. So you don't get anywhere near the same peaks and valleys that you would in a production environment. And it's like, okay, yeah, the machine learning works for something like production, but I also want it to work for staging because we're spending a lot of money in staging too. And I want it to scale down, to whatever's minimal. So you get these kind of options based on what the cluster is actually doing or the service is actually doing. And that's what's exciting to me. It's like, I got an EU environment over here that behaves very different than what NA does. And I don't want them using the same recommendations. I want to be able to apply them differently and take that kind of thought and say, hey, I need engineer to go do that for, all of these different environments, right? That's next to impossible. Like it doesn't scale is a good way to say it.
Mm-hmm.
It's a great way to say it. It doesn't scale. And that's why we're all here having this conversation. And that's why we're really looking forward to the launch and especially the partnership we have with you, Chad, and where we kind of take that forward.
Likewise.
So I wanted to thank all the panelists for joining us today. Chad, thank you for your time. James, thank you for your time as well. We really loved having both of you on here. And Liko, of course, thank you for your time. Not all the time. And now we're going to kind of transition to talk a little bit about our announcement, go into the news from Stormforge.
Thanks, Hamza. Thanks, Liko.
Hey, thanks y'all.
All right. Liko, I would love to pass it over to you to introduce our announcement.
Sure. Yeah, then so I'm pumped as all get out to talk about bidimensional autoscaling with OptiLive. Go to the next slide, please. So the challenge we've seen is that folks, if they are so inclined, will set up the VPA to right size their existing deployments of pods. But that requires a lot of manual effort. And to that point, as you see in one of the bullets, Datadog, one of our partners and friends, has an annual report where they talk about usage of different cloud technologies, especially around Kubernetes. And while HPA is very popular, less than 1% are using the VPAs. And I think that's because there's too much manual configuration involved. The other element, the HPA, is the most popular by far, and a lot use that. But the challenge you have with the HPA is that it ends up stamping out that same template of, if you were wrong in the first place, resource-wise, you keep doing that, and all those replicas now multiply out. Like I was going to say add up, multiply out. So you have so much inefficiency and waste, and it's just frustrating. Next, please. The other challenge that we have with the autoscalers is they can work against one another. They're not aware of one another. So you'll have the HPA trying to add replicas, for example, to get the utilization to 50% because that's the target that it was set at. But meanwhile, the VPA is seeing its utilization go down, and it's going to reduce the resources that are applied to that existing deployment or pod. So they're kind of working against each other in a constant just competition. And frankly, no one wins in that state. And unfortunately, it leads to applications going down instead of providing efficient availability, which is what our goal is. So what if you could autoscale vertically and horizontally without them fighting, without contention, to maximize the efficiency of the resource and not sacrifice any of your application performance?
Well, Liko, what if I told you you can?
Oh,
So-
tell me.
I'm super excited to announce that we are our new feature in Optimize Live is enabling bi-dimensional pod autoscaling. We're super excited about this. The team's been working on this for the past few months, and it extends our capability of providing vertical pod autoscaling to, in addition to that, set the target utilization for horizontal scaling so that you get the benefits of vertical scaling while also not sacrificing reliability. Our organizations can still use the HPA for scale, just much more efficiently. So we'll automatically, with the machine learning, set our CPU and memory requests and limits, in addition to the optimal target utilization for the HPA. We're super excited about this. It's still based on collecting observability data, running machine learning, and in real time giving you those recommendations. And that can be set whether it's an hourly recommendation, a daily recommendation, that's all for the user. But they no longer need to choose between cost and reliability, and they can reduce their resource usage while maintaining that high level of performance and reliability that most organizations desire. So I want to go through a few scenarios of what this looks like if you had no auto scaling. Chad earlier mentioned, when you start to be over provisioned, some of the challenges are you're setting your CPU requests artificially high because you want to reduce risk. You want to reduce risk of performance, reliability issues. And the bad thing, though, here is that it results in wasted resources, and you're not optimally setting your CPU. In an under-provisioned use case, you might set that CPU request lower to try and reduce your utilization. However, the challenge here is it leads to CPU throttling. It can result in performance and availability issues. So both scenarios are not ideal, over-provisioned or under-provisioned. And many organizations will then deploy an HPA so that they can set those CPU requests to be lower, still high enough to reduce the risks of usage spikes and handle that, but they can set it to a lower amount because they know that the HPA will kick in and add replicas as needed. So it's less resource waste. However, something Liko mentioned earlier, most organizations are just taking whatever the default is, setting it at 60, or maybe guessing on what that target utilization should be. And oftentimes, and specifically in Chad's example he shared, it still leads to a lot of wasted resource. Not as much as just setting your CPU request artificially high, but still significant. So with Stormforge, with our bidimensional auto-scaling capability, we enable users to continue to use their HPA and dynamically set that target utilization for them to the most optimal point. So in addition to using the machine learning to provide recommendations on CPU requests and limits and memory requests and limits, the machine learning will also recommend the optimal target utilization. So the best point where you're reducing your wasted resources and still hitting the scale that you need and still making sure that HPA is adding pods and removing pods as needed to handle your workloads. This is a preview of what it looks like in our product. So as you can see in the bottom right, that's where we provide our recommendations for both requests and limits on CPU and memory. And if an HPA is detected, so if you have an HPA deployed, we will give you that recommended target utilization. And if you don't have an HPA deployed, we'll still act as a vertical pod autoscaler and we will provide those recommendations. But if we detect an HPA, we will do that in addition so that you can get the horizontal scale organization that you would like to. And in addition to that, make sure that you're doing it in an efficient manner. I'm going to pass it over to Liko to do a demo and show us how this looks in real life.
All right, thanks, Yasmin. So here I have a Grafana dashboard, which is kind of showing you, this is something we get to do in our solution architecture organization all the time as part of a proof of concept. I have Optimize Live running with the bidirectional scaling enabled here. And this is the Google Microservices demo you can find in their GitHub. It's one of my favorite things to use because it has 11 components that all work together to provide a kind of retail front end to do some shopping. And with that in mind, these different components are all here. What I've got on this graph is a live environment. May the demo gods be with me. And what we've got here is some utilization going on And it's actually gone down in the last little bit. And you'll see that our recommendations are staying steady at the moment, but that's because it's been watching it historically where it was, and we were real tight. We were real good with what that was showing. But overall, the savings compared to what it's been set to, you see here it's been set to 500. We're recommending that it can get dropped down to 211 from a millicore of CPU perspective. Now, this is kind of the VPA element of that as well. However, with that said, you also see here something called recommended scale point. What that's saying is, and that's that line right here, that's saying that if the CPU is hitting that point, that's where we want you to add another replica to keep that average where it needs to be so that you can continue to scale, continue to meet the demand. So here we're looking at the ad service. There's also a cart in here. So that one we're saving about 31%. You see a little bit more activity going on here. And we would argue that you should scale about right there. So maybe that would have been a scale moment. In this case, I have this running in a bit of a manual or read-only mode where it's not taking these recommendations automatically. And there's also some tolerances you can set. So in these graphs, I have it set to medium, which is the default out-of-box experience. But let's say we can be a little more aggressive with that. We'll see these values change to where our recommendations get a little tighter and the savings get a little higher. Now, this is, again, it's a live environment, but it's also looking at all of the facets that should be considered with a customer application. And so with that in mind, let me also look at Redis. Now, Redis, in this case, Redis doesn't use a lot of CPU, but historically, Redis will always use lots of memory. It's an in-memory cache. And on this site with the load I have generating against it, this doesn't seem to be too busy at all. So clearly, that can get dropped quite a bit, and we can even scale at a really, really low point of about 28 millicores is what we were suggesting. But I think the other interesting thing I'll point out here, let me scroll down on this page a bit. Redis is known for its memory usage and how it uses memory. And yet, in this instance, we're still seeing that it only ever got up to about 7.5 megs in the last 3 hours, for example. So really right now, we could have saved almost 3 gigs per hour. And I think that's a really interesting point of view to take, because if we were to take that recommendation from Optimize Live and apply it to this environment, then what would happen is that as these scale points happen, if I go back up here to see them again, as these scale points occur, it can still scale up and add additional memory where it needs it, or additional instances of Redis to perform that caching. And this applies across any application. You know, the ones I'm calling out here are not the only ones. This is just a simple demo environment. But I think it kind of shows that what you can see, the advantages of Optimize Live, especially considering both elements of this simultaneously. It's really exciting. So let's talk about the Stormforge difference. Yasmin, why don't you start us off?
Awesome, thank you. Then that was a great demo, Lico. What I love about our platform, I think what really makes us different is that we maximize the value out of data you already have as a user. So whether that's data you're generating from lists, or that's real production data that you have in your observability platforms like a Datadog or a Prometheus, we're able to take that data and do something with it, give you recommendations and deploy those recommendations to reduce your resource or improve your performance. We can kind of give you the most amount of value from data you already have as a user.
You meant to say turn observability and actionability, right? Anyway, what we've done, though, is for almost the last 6 years, we have Optimize Pro, not what we're talking about today, but that's where we gather a lot of information about how applications perform and how they run. And that really informs our machine learning and what it can do as far as providing insights into applications so that we can provide these recommendations with confidence that you can safely put this into automatic mode, which, by the way, is its default approach, and have this at scale across your entire environment. We're speaking earlier with both Chad and James about how Kubernetes scales out so broadly. There's so many things to take care of. Why not let the machine do it for you? That's why it's here, and that's what we do. We have some patent pending machine learning algorithms that handle this and watch the utilization, compare it against what's been set to, and we squeeze that waste out so that you're running as efficiently as possible. And I get really excited about this because this is like what we've looked for. This is the nirvana state that I think anyone who's been working with Kubernetes for a while has been seeking, and yet here we are today. So I'm excited.
Yeah, I love that. And it's not just that, patent pending, it's 6 years in the making that our scientists have been working on this machine learning algorithm that really gives our users fast time to value. So it kind of takes a lot of the manual effort in, one, figuring out what your configuration should be, using the machine learning to come up with the right recommendations, but then also automatically deploying that for them. When you're an organization at a large scale, you have thousands of clusters, you want to go out and deploy all these changes. You can't do anything but automate that. And so the fact that we can pull in that data, provide those recommendations, and automatically deploy them continuously in environments gives our users fast time to value. So with that, if you'd like to learn more, we have a bunch of resources on our launch resources URL. And we're very happy that you've all joined us, and look forward to speaking again.
Yeah, if there's anyone who has a Q&A, we'd take those questions right now. Go ahead and type them into the chat or whatever is the easiest approach. We're here for you to answer questions you might have about our launch. And Yasmin and I are going to just buzz on out of here because we're so damn excited, I think.
All right, so at this point in time, I'm going to invite Yasmin and Brian to join us back up, and we're going to handle some of these live questions that we've received throughout today's program. So Yasmin, Brian, thank you both for joining me again.
You buzzed back here is all Cody, thanks.
Thanks for having us.
So I'll take the first question I saw in Q&A, Yasmin, if that's cool. So the first one was, does Stormforge take time to scale into account when configuring the autoscalers? So time to scale is actually configured more by your application and its deployment than anything we do. So we're setting, or we're recommending the points where we want, or we think would be best for your application to scale, and we'll apply those settings. But those are settings either on the deployment itself, as far as the resources are concerned, or they're on the HPA that you're using. So everything else is kind of controlled by how you have your application configured. Most folks who have deployments configured with multiple replicas also set values for random timeouts. There's too many settings to go through in this webinar, but timeout values that you need to set. And so that's basically always respected by Kubernetes, regardless of anything we're doing from our platform perspective. But thanks for the question. That was a good one.
I'll take the next question. Someone asked, are we talking about scaling here or monitoring of scaling? So our product and our platform gives you recommendations for actual scaling. So we act as a vertical pod autoscaler, and we give you recommendations for requests and limits on CPU and memory. And then we also recommend the target utilization that you set your HPA to. So you can continue doing horizontal scaling as you have configured in your platform. We just give you that recommendation for the optimal scale point. So we take in the inputs of how you're doing your scaling to feed it to the machine learning. But what we do is we provide those recommendations to do the actual scaling.
Yeah, I think that addresses that one. Next one I see here, we have a bunch, so this is great. Thanks. I keep asking, by the way, these are good questions. Next one I see is, do we take error budget into account? So error budget is specifically at the Kube API level, and we're not really paying attention to that element because the work we're doing is more at a higher level. So what we're doing is we're telling the Kube API at the interval that the customer specifies, yes, take this recommendation on and apply this directly. That is only going to hit the Kube API hard enough to cause errors in very extreme circumstances. In other words, if you have maybe a namespace that has, tens of thousands of objects within it, which if you do, I'd love to know how you're doing that. That would be when that sort of thing happens. But we're not in the space of any application performance monitoring. Like, that's not our goal. We don't want to enter that space. We have partners who do a much better job than we could ever do. So that's really where we'll leave that to those environments. We don't take that into account today. And frankly, I don't see a reason to. But again, ask again if you have more data on where that question was coming from, because I'd love to talk more about that.
Next question I see in here is, are you guys ever afraid of oversaturation with optimization skills? Numerous people are being self-taught with certain infrastructures, especially with tools being sold on eBay, Amazon, or YouTube. I would like to just, call out that as people are using tools available to them to skill up on optimization, that's great. It's great for everyone involved. I'd kind of argue we're not at that point or close to that point, just from the organizations that we speak with and the lack of skills out there when it does come to autoscaling and optimization. We'd all love to be at that point where there isn't enough room for optimization. But I think where we are at today in the industry, there's a lot of opportunity here.
Yeah, totally agree. I mean, I'd have a lot less meetings every day if people were more keen on optimization than they are. So next question I see in here is what teams are the common users of Stormforge solutions? So what we talked about today, Optimize Live, is it tends to be, I'll call them generically the cluster owner. So sometimes this is the SRE group. Sometimes this is yeah, just cluster owner or cluster admin. I'm not sure, every organization has different title structures, but those tend to be the folks who use Optimize Live the most. And that's because they have the viewpoint that is more broad than an application. Application team tends to be isolated to their own namespace or namespaces, and they don't really see beyond that, and frankly, don't care beyond that. Like they're not, some organizations are super mature in this space and have show back and charge back where they're like charge per namespace. And in that point, an app team might care a little more. But generally speaking, what I see is they often only the cluster admins are the ones who engage with maybe the FinOps team or the finance organization who are complaining about the costs and ultimately trying to drive that out in a more data-driven way, which is what we can provide with Optimize Live, especially now with the new scaling features.
Awesome. Totally agree. The next question I see is what type of savings are you seeing most organizations get with Optimize Live? So I will say, results may vary, but what we see typically so far with the organizations that we've worked with is anywhere between 40 to 65%. I'll say that sometimes we see much higher than that, and sometimes we see lower than that. It really depends on the organization's workload. But oftentimes when we're working with folks that do have an HPA enabled, they're finding themselves to be heavily over provisioned. And so there's a lot of opportunity, and depending on which application and the environment, it'll vary slightly. But generally, we kind of find that being the sweet spot.
Do you want to take the next one as well? Yes.
Yeah. Is this feature dependent upon deployment model on-prem versus public cloud? It's not. So anywhere you have Kubernetes deployed, so whether that's on-prem Kubernetes or AKS, EKS, GKE, sorry, lots of letters. Any Kubernetes deployment, we are compatible with.
Yep. So next question's a good one as well. That Google has a similar product called multidimensional scaling. Can you explain the differences? The biggest difference that I could call out is that Google's is in beta still, and they have not GA'd it yet, and it still requires you to put a bunch of manual boundaries on it. It doesn't have any machine learning that informs what it should set any of the values to. And so earlier in the broadcast, I talked about how you end up having that mechanical Turk. You end up having that need to manually set a lot of parameters. And at least in my investigation of this, I couldn't find how you could set this in an automatic way. So Google's a partner of ours, so I don't mean to disrespect anything they're doing. Any work in this space is great work. Like this rising tide will float all boats, right? This will make everything better for all of us. But I don't see how that's going to work really well. Plus, I'll tell you something unexpected, perhaps. Most of my conversations with customers are about their on-premise Kubernetes deployments. And I know Google has one of those, but I'm not sure that this works with that. I think it only works in their cloud environment today. Don't want to speak to that. You'd best speak to them about that element of it. But I think that's what I see as kind of the limiting factors of what Google's up to. And again, I can't wait for what they do because it's only going to make all of us better.
That's a great answer. You want to take the next one?
Sure. So as far as providing, the question is, does Optimize Live provide cost comparative info? You saw in my share there, I was showing the percentage of savings. That's relative to like what we've recommended versus what the current setting is, and then how long it's been set that way. So that's where you saw like that 59.5% number and some of these other numbers. That's all we're going to surface because frankly, again, APM platforms are much better at interrogating the underlying infrastructure and then letting you input the values and kind of exposing those up. So we'll show you the percentages just to give you kind of that peace of mind of, wow, this is a really good one. Or the one I didn't show, you might have noticed I skipped around there, right? I skipped a bunch of the ones between the Redis cart and the other cart. There was one that only showed a savings of like, I think 6%. And I'm telling you this because we have nothing to hide. Like it's going to vary, as Yasmin said earlier, it's going to vary from deployment to deployment. Some are sized appropriately. Most are not because they're punched out of some template or cookie cutter style. So I think with that in mind, we don't want to get into that business. We're going to leave that to our partners who do a much better job. If there's more, though, we'll welcome the feedback. If there's more information we could expose that would help you integrate this into your APMs better, please let us know. But all of the data used to generate those graphonographs are from our tool and can be incorporated into any of the tools you already use pretty easily. I think I'm going to take the next one too. So next question was, how fast is the learning phase of the machine learning? Our machine learning, when you launch Optimize Live, looks at the past 2 weeks history of work. Now, as far as how fast that is, it's as fast as it takes to ingest the 2 weeks worth of data. The data we're taking in is the utilization, both CPU and memory wise, as well as the HPA details. So the replica counts and the set points, as well as where it currently is on replica count, where it was over those 2 weeks. So if you have, and forgive me, I don't know what the fastest infrastructure is anymore. I like to think I'm using it every day, but whatever the fastest is, if you load in all those 2 weeks, that's as long as it takes. The machine learning at that point is going to do its work almost immediately once it has the full, we call it the backfill process. The backfill process is complete. So I would say the fastest I've seen is somewhere around about an hour, and the longest I've seen is about 7 or 8 hours, and that's with some older, slower infrastructure. I do a lot of proof of concept work, so these are in like labs, or I jokingly call it the leftover hardware. So maybe it's not the fastest.
That's awesome. I think that's all the time we have for questions today. Just going through the list. We could pass it back over to Cody to wrap us up.
All right, Yasmin and Brian, thank you both so much for jumping on and helping out with the Q&A. And I would also like to send a big shout out to both James and Chad, who were with us today during our presentation but could not stick around for the Q&A. So a quick reminder to our audience today that this session was recorded. So following this, you should receive an email with a link to access the recording on demand, or you can find it living on the DevOps website at devops.com/webinars, and just be sure to look in the on-demand section. So we did mention at the top of the hour that we'd be giving away 4 $25 Amazon gift cards. Our 4 winners are Edward B., Gordon M., Hazeline C., and Kieran H. So to our 4 winners, congratulations. Please keep an eye on your email inbox to claim that gift card. But if you don't happen to see that email, just check your spam folder. I would like to thank Stormforge for sponsoring today's program and putting together this expert panel. And to our audience, thank you so much for spending time with us. We appreciate you taking time out of your busy schedule to be here. And we just want to ask for one more moment for a quick survey that should pop up on your screen as soon as we close out. Otherwise, we hope everyone has a great rest of your day, and we hope to see you at an upcoming Techstrong Learning program. Yasmin and Brian, thank you. And to everyone, have a great rest of the day.